Imagine the vast, silent expanse of deep space. Billions of stars glitter like diamonds on black velvet, entire galaxies swirling in a cosmic dance that has lasted eons. It's a universe of unimaginable distances. To travel from one side of our own Milky Way galaxy to the other would take light itself over 100,000 years. But what if there was a shortcut, a cosmic secret passage that could connect to incredibly distant points in an instant? This is the mind-bending idea behind a wormhole. Hello and welcome. Today, we're venturing into one of the most fascinating concepts in modern physics, wormholes. Are they real? Could we ever use them to explore the cosmos? Let's unravel this mystery together. So, what exactly is a wormhole? The official name is an Einstein-Rosen bridge, named after the two brilliant minds who first proposed it, Albert Einstein and Nathan Rosen. But let's use a simpler analogy. Picture a large sheet of paper. On one end, you draw a dot, and on the far end, you draw another. To get from the first dot to the second, you have to travel all the way across the paper. That's like conventional space travel, a long journey. But what if you could bend the rules? Imagine folding that sheet of paper in half, bringing the two dots right next to each other. Now, you can just punch a hole through the paper, creating a direct tunnel from one dot to the other. That tunnel, that incredible shortcut through spacetime, is exactly what a wormhole is. It's a theoretical bridge connecting to separate points in the universe, or perhaps even to different universes entirely. This idea comes directly from Einstein's groundbreaking theory of general relativity. He taught us that space isn't just empty nothingness. Instead, he described it as a flexible fabric, something he called spacetime. Massive objects, like stars and planets, create dips or curves in this fabric. This curvature is what we feel as gravity. A wormhole would be an extreme case of this curvature, a place where spacetime is so bent and warped that it forms a tunnel. Think of it like a whirlpool in a river. The water flows and bends around objects. A wormhole would be like two whirlpools in different parts of the river that are somehow connected beneath the surface. You could dive into one and pop out of the other almost instantly, bypassing the long journey along the river's surface. In the same way, a spaceship could theoretically enter a wormhole in our galaxy and emerge in a completely different one, millions of light years away, in a fraction of the time. This all sounds amazing, right? So why haven't we booked our tickets for a trip to the Andromeda Galaxy? Well, there are a few very big problems. The first major hurdle is stability. According to our current understanding, a wormhole, if it could even form naturally, would be incredibly unstable. The moment it opens, it would collapse in on itself faster than the speed of light. Anything that tried to go through it, whether it's a single photon or a whole spaceship, would be crushed in an instant. It's like a soap bubble that pops the second it forms. To keep a wormhole open, scientists believe we would need something truly extraordinary, something with properties unlike anything we've ever discovered. They call it exotic matter. This isn't just matter that's rare or from another planet. It's matter with negative energy or negative pressure. Imagine something that pushes outward instead of pulling inward with gravity. It would act like a cosmic scaffold, propping the wormhole open and preventing it from collapsing. The problem is, we have no idea if exotic matter actually exists or how we could ever create or control it. It remains purely in the realm of theory, but let's be optimistic for a moment. Let's say we solve the stability problem. We find our exotic matter and build a stable wormhole. Would it be safe to travel through? The journey itself would be unlike anything we can imagine. You wouldn't be looking out a window at passing stars. Instead, you'd be inside a tunnel of distorted spacetime. The tidal forces inside a wormhole could be immense. These are the same forces that cause tides on Earth, but ramped up to an extreme level. They could stretch and squeeze a spaceship and anyone inside it like a piece of spaghetti. Designing a craft that could withstand such forces is another monumental challenge. Now, let's touch upon an even more mind-bending possibility: time travel. Some theories suggest that wormholes might not just be shortcuts through space, but also through time. Imagine one end of a wormhole is kept stationary, while the other end is taken on a journey at near the speed of light and then brought back. Due to time dilation, a key part of Einstein's theory, time would have passed much slower for the moving end. So you could enter the stationary end in the year 2050, travel through the tunnel, and exit the other end in the year 2030. You would have effectively traveled 20 years into the past. This opens up a whole can of worms, famous in science fiction, known as paradoxes. The most famous is the grandfather paradox. What if you went back in time and accidentally prevented your own grandparents from meeting? If they never met, you would never have been born. But if you were never born, you couldn't have gone back in time to stop them from meeting in the first place. It creates a logical loop that seems impossible to resolve. Physicists are still debating how the universe would handle such a situation. Would it be impossible to change the past, or would it perhaps create a new, alternate timeline? The questions are as fascinating as they are complex, so where does that leave us today? Have we ever seen a wormhole? The short answer is no. Despite astronomers pointing their powerful telescopes at every corner of the sky, we have never detected any sign of a wormhole. They remain a beautiful, elegant mathematical solution to Einstein's equations, but they are still purely theoretical. Scientists are actively searching for indirect evidence, like specific types of gravitational waves or unusual movements of stars that might suggest the presence of a wormhole mouth. But so far, the cosmos has kept its secrets. However, the lack of evidence doesn't mean the search is over. The idea of wormholes continues to inspire not just science fiction writers, but also generations of physicists and astronomers. They push us to ask bigger questions about the nature of our universe. What are the ultimate limits of space and time? What other cosmic wonders might be waiting just beyond our current understanding? The quest to understand wormholes is part of humanity's larger quest to understand our place in the cosmos. Perhaps one day in the distant future, our descendants will have harnessed the laws of physics in ways we can only dream of. Maybe they will build stable, traversable wormholes, opening up the entire universe for exploration. Imagine a future where the journey to another star system is as routine as a flight across the ocean. Humanity could become a truly interstellar species, spreading out among the stars, all thanks to these incredible cosmic shortcuts. For now, wormholes exist in the space between known science and bold imagination. They are a reminder that the universe is far stranger and more wonderful than we can possibly comprehend. They are a beacon of hope for future explorers, a symbol of the endless possibilities that lie hidden in the fabric of spacetime. As we gaze up at the night sky, we can wonder if just maybe one of those faint points of light is not a distant star, but the gateway to another place, another time waiting for us to discover it. Thank you for joining me on this journey through space and time. If you enjoyed this exploration, don't forget to like, share, and subscribe for more deep dives into the mysteries of our universe. Keep looking up.